All right. Welcome, everybody, to our very first breakout session. We're excited to be here. And in this one, we are going to start talking about our Agentic AI toolkit for developers. And first, I want to start off with brief introductions. So I'm Brendan. I lead the developer product teams here at PayPal. And actually, there's a whole bunch of us outside at the Voice of the Developer booth who'd love to hear any of your thoughts, feedback, and comment on our developer tools. But also with me are the actual stars of the show today, Vikram and Nitin, who are both on our AI engineering teams. And we're going to talk a lot about how we built these tools. So first, want to start with some basics just to set the level for everybody. You may have heard some of this before, but today we're going to talk a lot about MCP, or Model Context Protocol. If you haven't heard of this before, it's a new open standard that allows AI agents to connect to data, third-party services, basically anything else outside their immediate domain. And in some sense, the analogy we like to make is this is kind of like how we standardized on USB for the first time. So we all agreed on the same size plug, and suddenly everybody can plug things into other things without a huge hassle. MCP has a lot of advantages, right? It allows two-way connections, local or remote. You can go across devices. It definitely supports multi-agent flows, which is great. But first, we want to talk a little bit about some of the practical problems that it helps solve and show you in action. And then we're going to talk about how we built this and some of the design decisions we made. So let me start with the basics. If you think about a world way back when, before there were AI assistants, if a merchant or their agent wanted to do something unique, something specific. So the example we took was a merchant wants to create an invoice for a specific customer with specific discounts, basically do something custom. The workflow for this had a lot of steps. You probably had to go manually log in somewhere to a dashboard. Maybe you had to fill out some form or copy paste something. And then maybe you wanted to actually allow them to pay. So you sent them a link, a payment link of some kind to go pay this. And that was probably the easiest way you could actually do something custom on the fly. But now, it's actually far simpler. So same use case, I want to create a custom invoice, totally custom setup, send it to a customer so they can pay me right away. Now you can do it through a simple conversation almost instantly. And we're going to show you how that works. And actually, I'm going to bring up Vikram to show you how it's all possible.
Thank you, Brendan. Hey, everyone. Isn't this exciting, right? Now, merchants can actually use an AI assistant to directly interact with PayPal capabilities, right? Like creating an invoice in this case. So, and based on the AI assistant's tools capabilities, they could even give a simple voice command, right, to create an invoice, or upload a bunch of Excel sheets with list of details for which invoices has to be created. Now, how is this done? So let me introduce you to PayPal's Model Context Protocol server. In short, we refer it as PayPal MCP, right? PayPal has remotely hosted its MCP server to let merchants use it as an enterprise extension for any of their preferred AI assistants, which supports MCP client connection, right? Now, let's get into more exciting part. How can you, as a developer, use PayPal MCP to solve problems for merchants and their customers, right? And how does it make your life easier when building agents for merchants? Before PayPal MCP, if you wanted to create an agent with payment capabilities, you would typically have to build an entire agentic workflow, which involves identifying and invoking the appropriate PayPal APIs, mapping them to the correct APIs based on the use cases, parsing the parameters from the prompts, and handling the responses. But now, all you need to do is plug in the PayPal MCP server into your agent. It's like USB-C. Once connected, your agent is fully loaded with PayPal services. Now, let's take a look at an example, right? To see how this can help in implementing agents for merchants, enabling them to sell their products to customers, right? Let's say a merchant has reached out to you for help in creating an agent that assists selling their cookies, let's say, right? This way, they can focus more on baking the delicious cookies instead of spending time in taking the orders. Let's take a look at how this agent might work, from the customer's point of view. Let's say a customer wants to buy some of their favorite cookies, right, and reaches out to the merchant agent and asking for the cookie availability, right, like how many cookies has been left from the favorite cookies, right? Here, an agent can check the inventory in real time and respond back to customer with availability of the cookies. Now, let's say customer wants to purchase the cookies. If your agent is equipped with the PayPal MCP tools, like in this case, like if you have a function, by just adding this simple function into your agent workflow, this loads all the available PayPal MCP tools into your agent, such as generating an invoice link or payment link, right? So with this, agent knows that it has the payment capabilities enabled within it, and it is ready to take the order and send out the payment instruction to the customer. So let's say sending an invoice in this case for asking customer to pay for the cookies, right? So now agent invokes the PayPal MCP tool, and the toolkit will take care of invoking create invoice and send invoice capabilities within that, and to generate a shareable link and returns the response back to the agent. And the agent responds back to the customer with the link for paying. And now customer will be able to pay off for the order using the same invoice link. So here, if you see, the PayPal MCP server acts as a bridge, providing your agent with every access for invoking the PayPal payment capabilities. This way, as a developer, you can focus more on building or innovating amazing agent or agentic workflows for your clients and merchants without having to worry much about the underlying traditional APIs. So now that we have gone over the capabilities of the PayPal MCP, I'll hand it over to Nitin, who is going to dive into the design principles of the Agentic Toolkit.
Thank you, Vikram. So now that MCP is a protocol that's going to be widely used or has started to be widely used, what are some design principles that we should be thinking about here? And what we're doing for this talk is we are organizing it into 3 different sections. So the first one is who owns the tool and who can use the tool. So this is the very first facet of it. And broad stroke on it is this is all about tool organization and governance itself. So what you have to the right side is basically an example of what's a well-organized toolkit. Of course, there are opportunities for us to improve any toolkit as we go along, but for an example, we have that on the side. So the first idea there is the central registry. So the tool needs to sit in basically a standard location which is discoverable by agents, because this is all going to be about agent discovery. And we'll talk a little bit about this a couple of slides later, where how do external agents actually call, for example, PayPal agents. So for the tool to live in a central location is actually very important. So it should be a single source of truth there, and you could implement that as a catalog DB or a service. Access control. So this is a scenario where you want to restrict control of agents that are actually going to call the MCP toolkit. So not every agent has a blanketed capability to call it. We need some access control there. So what environments and what allowed agents should we be whitelisting to have access to our specific MCP toolkit? And these would be enforced through API gateways. The unique identity, which is the obvious one there, where you want to encode namespace and an upgrade path. So you have to have a unique identity. And so in this case, you have a domain of payments, and everything related to payments, basically all the tools that are associated with that sit in a standard toolkit affiliated with payments. Schema contract. So this is very similar to what you see in traditional API formats, where you want to have a very specific schema contract where input and output are explicitly typed and documented. And there is also a strict input-output JSON or open API. And we'll talk a bit more about how open APIs are actually taking wider precedence, especially when agents are interacting with each other, and then to establish that vocabulary there. We want to be able to validate that at runtime and build time, because there is contextual relevance that comes through it. So what you see here is basically an input, and then there's a type of object, and then you see a very specific schema contract that's actually described to the right side. Domain grouping. So because this is related to payments, the example here, we are classifying that as under payments.star. This, again, helps for easy discovery and orchestration. And so we are, a good guideline there is to define it by function name or by business name. Since these are toolkits, we do need to have policy guardrails around those. So some of those could be what should be a retry capability there, how much rate limiting you want to apply to an outgoing agent into a call into the MCP protocol, what are the timeout rules, and so that is defined to the right side through this policy block where we have a rate limit per minute, and then we also have retry on for the timeout and gateway, and then what is the timeout specification. So this is fairly standard to an external-facing microservice there. And we want to encode that in the middleware or the agent router with declarative config. So that way, you have the right guardrails for function calling, or what we call as callbacks. Auditing and traceability. So here, as you can see, the audit logging is true. This ensures observability because external agents are going to call the MCP server. And so we want to have the right kind of observability to understand who were the callers, when did they call, what kind of input-output format they had. And then we also want to actually hook this up with an audit DB. For example, you could have something like a Datadog setup or an Elk setup there as well if you want to actually be able to search in a free-form way. Lifecycle review. So very important there. MCP toolkits. What is the overall life cycle of a toolkit? What are the different toolkits that might be deprecated? So as you go along, there could be the scenario where you're building a lot of toolkits. Some of these are external facing, and then some of these could be deprecated because you're doing the same kind of development on toolkits that you are for your general software integrations. So and tools have to go through review stages. And so what you see here is a last review format, and then potentially also have MCP dashboards with those status tags. So after we address the question about the toolkit itself, now we want to know what does the tool do and how does it really behave. So then what are some of the constructs there as we are defining these? So one is modularity and single purpose, right? So the tool should be doing exactly one thing. So this is also where we want to have a single point of reference for tools and not necessarily have multiple tools that have multiple verbs associated with it. For example, I could say something like send, receipt, and validate email. Now, these are two different verbs, and we want to make sure that this is structured formally in a modular format and a single-purpose way. So design around verbs there. Concise input-output, which is very similar to what we talked about earlier, an ambiguous schema, not too deep nesting, so your observability is in place. And then safe evaluation. So because agents actually involve a lot of offline evaluation, you certainly are sending the agentic toolkits out there, but you want to be able to see what their behaviors would be. Most of these are associated with an LLM, and LLM responses can be notoriously non-deterministic. So how do you test for all of that in an offline setup? So you want to be able to have safe evaluation there. Explicit context dependency. So here you want to be able to signal upstream context, what is required upfront for execution of that toolkit. So here in this case, you require context keys like transaction ID and the user's email. Structured error handling. So in this is standard that goes with any API guidance where you want to be able to include code and retriable flag. So do you want your toolkits to be latency aware? Because downstream execution could actually involve multiple calls. Now you have toolkits or you have tools that might be calling multiple APIs. So now what is the cumulative SLA that is associated with those API calls that sit right behind the verb or behind the toolkit? So here again, we want to have essentially some guidance to the calling agent as to what the latency class should be and what's the maximum latency in milliseconds there. So the incoming agent can guide themselves for time budgeting there. There's also the runtime behavior contract. So here, what are the core behavioral guidelines? So you can have predictability, and you could have a very concrete documentation associated with that. So here, for example, this is a stateless runtime, and then the idempotency is also true, and then it requires authorization there. Last but not the least is composable planning, which really is the heart of a lot of the MCP framework, right? So you will have you'll have tools potentially being chained. So you might have one tool that is chained with another tool. And when you do this kind of chaining, you're having multiple steps that you're following with other tools. So you do want it to be easy to chain. So and once you're defining a toolkit, you want to make sure that the components of the toolkit are easily chainable, the outputs are structured, and there is certainly no deterministic guarantee, but you want to be able to provide a framework that actually pushes towards determinism as much as possible. So when you're LLM, so when you're working with large language models, you want to be able to have some deterministic guarantees on it being able to do a function call and then do the trace downstream. And last but not the least here would be the third question as to how does the tool evolve over time, right? And so some scenarios here would be, how do you monitor the usage pattern? Because now you have traffic coming into your agent, and how do you monitor those usage patterns? So you have metrics there that actually indicate what are the total number of invocations that your agent is having, the usage by agent, effectively rolling 7-day invocations there as well. And then how often and how valuable is the agent, and how broken is the flow? Because this will all give you guidance towards deprecation, towards management of the lifecycle of your toolkit there. The continuous integration validation checks to introduce that, to ascertain that you're latency compliant before promotion. So you have CI checks there on schema validation, on latency budget as well. The maturity tags on the tools. So there, again, you want to be able to differentiate between experimental environments and production environments. So here, the lifecycle is tagging this agent as stable. So it is good for the other toolkits to be able to call it, or other agentic frameworks to call it. Deprecation workflow that we addressed earlier. So here, we want to be able to, for instance, automatically sunset an agent when you actually look at potentially things like the usage patterns or the maturity tags and so on. So these flow in together, and then you might have a deprecation workflow there that might define flags like deprecation date, and then was there a replacement tool associated with it? Because once you deprecate it, you also want to make sure that any agent that was depending on it also doesn't just have to be left on a lurch here and has some fallback mechanism. The tool audits are extremely important here. So, so here we are identifying when was the last time this tool was used, and then so last used, and then again rolling 7-day invocations could be indicators of that. The change history and reproducibility is another important metadata artifact. So you could also support rollback and reproducibility, which applies to a lot of the software engineering frameworks. The lifecycle dates here are identified to understand what the time-based governance is, and also to automate audits there. And backward compatibility, right? So this applies to most of the software versioning, and agents are not immune to that. So we want to be able to encourage agents to check the replacement tool before they are migrating, or before the migration happens, and then the removal is scheduled there. And the tool changes should not break the existing usage. You are actually chaining a bunch of tools here together. So if there is any tool there that actually becomes backward compatibility problematic, then we want to have some kind of fallback mechanism there as well. So we have replacement tool identified here as a strategy. OK, so that sort of gives us some guiding principles around toolkit design. Now, how do you secure an MCP-based end-to-end call between client and server? Because you could argue that these are actually exchanging a lot of context. You're actually exchanging context between the client and the server. And a lot of times, this context could contain information that needs to be secured in some way, or also envelopes that need to be secured. You could potentially have PII information. So how do you secure your MCP calls there? So what you see to the left and right here are examples of insecure MCP envelope as a request and as a response. And what we've outlined to the left side are a bunch of risk categories. So the primary gotcha here is really oversharing, right? So is your MCP envelope really including fields that are not relevant to the tool here? So there could be some examples here. For example, you have shipping address, right? Is it necessary for you to overtly specify this for this specific tool? Because there could be an oversharing risk there. And there are ways to transmit that information securely. There could be PII leakage in the logs. So then what is the risk of leaking sensitive fields to logging infrastructure? Because you might have logging processes that are running in the background that are tracking all the MCP calls. So then is there any PII leak that happens in the logs there itself? Unencrypted credentials, which are identifiers in plain text in the envelope. So you find some of that here as well. Replay attacks, where you could reuse the envelopes repeatedly to replay an attack there. In this scenario, we also see that there is a missing HMAC or a JWT signature here, so that could allow tampering of the context as it's on the way. Context scoping, which is extremely important. So here, in this scenario, you could provide more context, because all of this is about context, right? Like you're sharing context back and forth, and then you could potentially enrich context as you go along. Like, for example, you might provide some initial context to the server. The server might say, well, I don't have enough information to process this further. It might come back to the client. The client enriches that context. It comes back. So these systems also have memory. So then it also becomes important to have an appropriate context scoping in each case. The ambiguous agent identity is again another scenario. So you have agent ID here. For example, that field could potentially be spoofable if it is not verified. So certainly a consideration there. Lack of output field control, where if your PII is leaked, can it be leaked to some downstream agents? Because while this agent might actually leverage PII in an unauthorized manner, does it end up leaking any information to downstream agents? That actually is an important consideration. Input validation, as is very important, where you want to make sure all schema violations happen upfront and then also at runtime there as well. And policy enforcement needs to also happen, where agents may invoke tools outside their scope. So what are the mitigations against that? So is the agent authorized to actually call a specific tool, and if it is within the scope? And what we have here now is an improved MCP envelope. So we showed you ways in which an MCP envelope could be compromised, certain practices that should be avoided, and now here are some practices that are generally followed. So first is the obvious one, where you have TLS or MTLS secure data in transit. So that actually works pretty well. And then you have the HMAC and JWT signature, which was missing previously. So now you can see that all the way at the bottom there, where in the security tag. We also have nonce and IAT, which are essential for any kind of replay attack. Schema validation here is done where you reject any malformed or oversized schemas that are overtly prescriptive there. Field level encryption. So this actually prevents raw credentials to be transmitted and also minimizes the PII exposure. And then PII tagging. So if there is any data attribute that is PII sensitive, as you can see in the context, user's email is specified, but also there's a tag of PII being true, and the fact that that needs to be encrypted. So all of these guidelines have to be relayed as context exchange happens. And then in the context scoping, we discussed earlier that only the whitelisted fields need to be passed through. And we don't want to have PII in the response, and that is the case, as you can see on the right side. And last but not the least, we do want to have tool policy enforcement, which actually prevents any kind of unauthorized agents from calling this tool. So we have an enforcement guideline, as you can see in the improved envelope. OK, so we talked about MCP. We talked about what the best practices could be, and then how do you secure an MCP envelope. But then what's beyond MCP? Is MCP the be-all, end-all? We see a lot of your social feeds probably going awry with a lot of people trying a bunch of experiments around MCP. So is that really the be-all, end-all? And so we are starting to look at PayPal. We are already starting to look at what other protocols could be in place, and how could we actually leverage those protocols? What are the pros and cons of all of these protocols that could bring this whole ecosystem together? So in that sense, we've also been looking at A2A, which is Google's agent-to-agent protocol, which has been released. And the broad stroke on it is, while A2A actually provides dynamic cross-agent discovery and task delegation. So you could think of A2A or agent-to-agent framework that operates at a much higher level of abstraction. And so the context exchange that happens there is bare minimum. So you could argue that you're not sending a ton of context, but you're just allowing discovery capability through agent cards. So for example, an external agent calls a service, and that service makes it evident as to what agents are discoverable, and that could be capable of handling the task at hand. And once that agent is called, then in the background, you could actually execute very specific and nuanced MCP toolkits, which now involve function calls and orchestration at the back end. So to that effect, you have some characteristics here. A2A is a cross-agent coordination and delegation mechanism. MCP is more typed tool and memory invocation in the agent. So it's right behind the agent, and it helps with the more granular orchestration and heavy lift. We talked about scope there, so multi-agent workflows. Here it could be, you could argue that you have an agent trying to do a broad stroke discovery on what are agents that are subject matter expertise, if you will, that have the subject matter expertise. For example, you could have a weather agent, or you could have an agent that provides you with information about your finances and so on. So that scoping actually happens in the agentic workflow with A2A. And then MCP is an in-agent runtime execution. So once you are inside the agent, once you've figured out what agent you want to call, then you have an MCP framework that tags along with it. The data model is predicated upon agent cards. We have an example of that in the next slide. And then on the MCP side, there is envelopes with schema validation. We saw some examples of that in the previous slides. The transport mechanism, standard, you have HTTP, JSON, and then SSE. And likewise, on the other side, where you have RPC 2.0 over HTTP. So I think the transport protocols, there's not a ton of distinction there. From a security point of view, since you're not doing a ton of context exchange at the agent level, so here you have agent level authentication. There are some trust policies that I can trust this agent. It can do its job through an agent card discovery, and there is broker scoping there as well. And in MCP, you need explicit envelope signing. You need nonce and IAT attributes there, and PII identification there. The use cases, as we talked about, is delegating the tasks to agent. So that's usually the A2A protocol. And then MCP, like once you've assigned a task to the agent, then how do you actually heavy lift your way through the last mile? And so that's where you have a data fetch or compute tool stack that sits right as a part of the MCP. Integration, again, you're handing off from one agent to another. That's basically the classic agent orchestration in A2A, as the name itself suggests. And then on the MCP side, this is called by agent once the planning is done. So you've planned to call the agent. You've discerned that that's the agent you want to call. And then, sure, you could have fallbacks in place, but that's the agent you're calling. And once you call that agent, then you have the MCP kicking in. So this is a high-level example of, and it's a reasonably simple example. It's just an illustrative example here that just demonstrates the flow. Again, there are many variations of this possible. But on the broader stroke, you could actually think of protocols as complements, so how A2A actually complements an MCP protocol. And here you have an example. So the user actually calls merchant's agent to buy a certain item. The merchant's agent looks up the A2A broker, and the A2A broker helps the discovery process to find the PayPal agent. The A2A broker actually reverts back with what is called as an agent card. So agent card is the identity here as compared to envelopes that you had in the MCP sense. So here you have the agent card retrieves information like what's the endpoint, what are the capabilities of this specific agent, and then what is the trust level? Is it how much can you trust this agent, and then what is the versioning on it? Once the merchant agent discerns that it is good to go and it wants to have further calls to it, there is an authentication mechanism that happens at the PayPal A2A agent. You receive an auth token, then you can instantiate a checkout request or a checkout for the service, whatever service you're looking for. Once that happens, now you hit the MCP client, because now the contract between the two agents is now fulfilled. There is a decision that has already been made that this agent will potentially fulfill the request. So then the agent hands it off to the MCP client. And so you can see the envelope construct here as compared to the agent card construct, as you can see on the other side. So here you again have a post MCP invoke on the MCP server. The corresponding tool is called, and then the stack flows all the way back to the user with a completed request. OK, great. So what could be some of what is really the landscape today, right? And the way we are seeing it here at PayPal, we see that the landscape is complementary, right? So you have A2A, you have MCP. There's also Open API. So some of these protocols are evolving over a period of time. So there is a distinct but still interlocking role play here that is coming about different agentic flows. And then here, the idea here is you not only want to orchestrate across agents, you also want to secure data across agents, and then you want to execute agentic workflows, which then happens through a combination of A2A and MCP. So some of the emerging directions here are basically, so universal tool registries. So could there be centralized locations for agent discovery? And here, Open Protocol for AI or OPI these are emerging protocols now as well for us to consider. Event-driven and pub/sub protocols, where you do want to have real-time integrations there as well. So when an event is triggered, maybe you want to trigger the agentic flow upon triggering the event. So then the event-driven and event-aware mechanisms become important. Privacy preservations, we talked about that a lot as to how to privacy preserve it. What could be some vulnerabilities that could be exposed because of just bad practices that could stem there. And then standardized state channels. You're tracking states of agents as agents are making calls to each other. So then what is a standardized way to track, or dashboard-oriented way, where I can track the states of each agent as the flow is being executed? And then you have the so-called digital twin protocol, where you have this notion where I might have a system that runs in production, but then I might also have multiple agentic systems that are running in stage or QA. And how do I ensure that I have sort of this digital twin protocol where I'm able to still safely test agentic behavior in environments that are non-production? The key themes here, as we see, first of all, interoperability, right? So you want to be able to have systems that can talk to each other in a seamless, interoperable way. we are also relying a lot on security and privacy of these of data exchanges that are happening in this process. Governance and compliance becomes important because a lot of, like in the old world scenario, you could have the API proliferation approach where a lot of APIs are being built, a lot of microservices are being built, and toolkits are not immune to that problem, right? So there's also still the need for governance and compliance of these toolkits. The developer experience then is also very important here, clearly, because your developers are eventually going to integrate agentic flows. So this becomes an important consideration. So this is sort of a high-level view of the MCP toolkit and some of the approaches that come about, and some of the key takeaways that we want to be conveying through this talk, right? And I think generally, I think there are 5 different areas. First is standardized orchestration, which we alluded to earlier. Out-of-box implementation, so you want these agentic toolkits to be as ready as possible without much integration effort and seamless, and Vikram and Brendan pointed to that earlier as well through the various demos. The rapid agent assembly, that means you should be able to use MCP-compliant primitives quickly and then make a composable framework where you're able to assemble the agent pretty quickly. So you might have multiple capabilities. There needs to be a way by which we should be able to discover the agent quickly and then also assemble the capabilities fast enough. We want modular and observable design with built-in governance. And then certainly a lot of focus also is on cross-agent discovery, as well as networks that could be decentralized as well. So 5 standard takeaways there as we come about. Great. So we have the MCP toolkit, and I think Vikram mentioned about it earlier. And you want to find out more about it, PayPal.ai is it, and we also have a QR code associated with it. So yeah, and thank you all for taking the time to attend today's talk. Yeah. I see we have some time here. If there are any questions, we are happy to field them. Sure.
The question was, do you guys support OAuth tokens as part of the MCP server invocations or not?
That's right. So there are 2 parts of it. So PayPal has opened up the MCP server both in the toolkit option and the remotely hosted option. So the remotely hosted MCP server is actually connected by merchants over the OAuth handshake. So any of the preferred AI assistants, like Claude Desktop or Cursor, which supports the MCP connection, can directly talk to the remote MCP by logging in with the username and password. So they can directly add as an extension to their assistants.
Sorry, just a follow-up question. You said merchants token. How does the consumer identity get passed along in those calls if they're placing an order, for example?
Yeah, here actually, the same remote MCP server, we can actually open up the order tool creation for the consumer use cases. Here, most of the invoice creation use case which we spoke about is a merchant-based. So as the OAuth still stays the same integration for both consumers and merchants. Yeah.
There's a question in the back.
Thank you. One question, how would the work of a QA engineer look like? So how would you end-to-end test an agentic workflow with this toolset? Thank you.
Yeah, I could take that. So I think in general, when we look at MCP toolkits, they are predicated quite a bit on defining the environment with a lot of concrete granularity. And then you saw there was this digital twin protocol, right, that we talked about in the last slide. So all of these mechanisms are actually the anticipation. I mean, a lot of this is still evolving technology, but the anticipation here is we want to make QA environments as replicable as possible to production environments. And this turns out to be an incredibly hard problem where LLMs are involved, right? Because you are triggering an LLM flow in QA as well as in dev. And then will you still get the same reliable function call in prod and QA? there is still a lot of work that is going on in this area, and I know there are to some extent, guarantees on how the determinism can be established, for example, through proprietary frameworks, OpenAI, Gemini, and so on. And then there is considerably more work when you're dealing with open source models there in that front. So I think to your question, I think you could put a lot of the function call guardrails and then potentially use generally function callbacks that are reliable through tweaking the parameters, like background parameters that you might have in the LLMs. It still doesn't necessarily guarantee determinism in QA that you want to reproduce in prod. And so this is a great question, right? This is still an evolving area. I think to the extent where you could establish infrastructure support and make it consistent across both QA and prod, that is the starting point. And then I think the other guideline that we've also seen that works very well is you basically, when you test cascaded functions, so often you have cascaded function calls, a lot of it also goes back to how good your toolkit is. So if you see that your toolkit design is very fragmented, then you might see a lot of cascaded calls, and then that leaves a lot more room for error, right, at the end of the day. So I mean, the overall idea is to still stick to the guiding principles at the outset, so that way the testing and the fallback that has to happen in QA and dev, or QA, dev, and prod starts to become more and more predictable. But this is a great question, and there is still a lot of granularity being established here. Yeah.
I'll get the question. Thanks. One of the slides, there was a talk about backward compatibility, right?
Yeah.
So considering all this in an agentic ecosystem, the providers are different, right? I mean, how, I'm trying to understand if underlying there's an API that's going to power any request, right? So when the signature changes, right? I mean, it's not backward compatible, right? You're bumping up the major number. That is definitely a coordinated activity in my mind, right? So, that definitely would slow down. So how are you guys? I mean, so far with the limited path that we have crossed, I mean, how has it been, and how do you anticipate that to?
Yeah. This again continues to be an evolving area, because again, designing toolkits is like the first step, like where you release your first few tools, you start organizing them behind toolkits, and then you'll certainly go through some version controls as you go along. I think there are some guardrails in the abstract agentic protocol. For example, you would have an MCP toolkit, and that MCP toolkit potentially has many. So you're still doing version control and tracking across those to the best that you can, as we talked about, like things like check if there is any staleness in the access and so on and so forth. So you're still managing the life cycle there to have as many guardrails as possible. There are some, I would say, there is some respite that comes from the upstream agent call, like for example, A2A. So when you're doing an agent card discovery, there are a lot more, it's expected to be a lot more rigorous, because that is your first check, right? So hopefully, I mean, so as agentic protocols evolve, hopefully there will be more interplay where you don't necessarily have to share raw context every time and then have some backward compatibility issues. You abstract that at a higher level as much as you can, and then allow a downstream process to take care of it. But again, like this is early days, genuinely. And so as we go through these cycles, I think we'll have to fall back on the traditional practices of how to release an agent. Not to go through a proper vetting process, and then if essentially also not to deprecate a full flow of agentic control, right? So you still keep one or two past versions active, so that way there is sufficient fallback there that happens. Yeah.
Hi. So I wanted to ask, like, how are you tracking that MCP client is making proper MCP tool calls? Mm-hmm. Or like, how are you making sure, I mean, are you tracking the first question? And second question is, how are you making sure that correct tool gets called all the time?
Yeah, that's a great question. So we have begun tracking a lot of this through our logging infrastructure, but I'll also let Vikram chime in more on this front, just to provide my 2 cents on it. So yeah, so I think a lot of it is logging and debuggability, right? So when an agentic call is being made, It's kind of the same sort of instrumentation controls that you have that usually apply to the traditional services where, I triggered an event. Okay, so that event maps to an agent call. Okay, so then what was the tool callback that happened? What was the sequence of tool callbacks? And if I'm running a series of iterations here, is that always reproducible? What is the distribution essentially of calls that fail, for example? Why are they failing? Are they failing because of a specific input that is being provided? Can we safeguard that input a little bit more? So I think this is generally the triaging process, and with LLMs being in place, there are always scenarios where we come across which are one-off there. But also, Vikram, if there's any thoughts there.
Sure. Just to add on top of that, so basically what we are saying is we are providing the list of tools to an agent, and agent typically uses an LLM to figure out which is the best tool. And what do we do to let the LLM do a best pick is based on the description of the tool, and how would we actually understand the prompt and match it to the description. So as Nitin mentioned, we have a lot of auditable, logging and retrying it based on all the capabilities. But ideally, it depends from LLM to LLM and model to model how it's going to act. So all the tool picking is reliable on the LLM. So if LLM changes, there might be a percentage of changing the tool picking capabilities. Yeah.
So a follow-up on what you have said. So do we have any benchmarks on what LLM is picking proper tools to call? And I mean, have you tried with various LLMs? In general industry, Claude is something which people say works best with
Exactly.
tools.
That's right. So most of the bigger LLMs, well-trained LLMs, have the 100% probability of picking the right tool. The description which we have provided for each tool, we have curated in such a way to, by testing with multiple LLMs. So that's how we came up with an initial benchmark. But obviously, with a lot of models coming into the industry, and we have to keep doing the same vetting with each and every model and try to improvise the description and connecting it with the prompt.
So I have a question about more like vendor side. So this is sales through the chat, right? With the AI. So basically, vendor hire AI agent for chat, and AI basically explain what's good, what's bad for the product. AI agent basically recommends product which customer want. So through the discussion, eventually customer basically buy it, make a decision to buy, and click the buy button, and all the transaction go through. So in that case, from my point of view, so AI agent really give a good explanation to make customer make a decision.
Yeah.
So or any kind of security during this conversation, or so if and then if customer wanna return or change their mind, and what happened? So I have used buy paper button a lot. So usually refund is made by our side, and they don't renew the inventory at all. That's a kind of problem. So this is a separate issue, but how do you think about that?
Yeah, so just to address the first part, and please let me know if there's anything I missed in the question. So explainability, right? So for example, like when customers are actually invoking specific calls, the explanation that happens as a result of the tool call stack, how reliable that explanation could be. So I think there is some standard practice there that comes through things like chain of thought reasoning in LLMs, for example, where you might, again, stack trace the call and then figure out exactly what was the reasoning process. If you enable the prompt action, what was the reasoning that actually went about in a specific function callback, such that you set up the debuggability trace, right? So there was a specific request that went through the MCP protocol. The server chose to make a series of calls. And then when you apply the COT module, like are those, like which parts of it were fairly randomized and some parts of it that actually had probabilistic determinism. For example, like there was very high probability for that function call to be made anyway, and it would have made that regardless. So I think a lot of it goes back to just the chain of thought reasoning on the stack, and then make sure that that becomes explainable. Like, so for example, you take the underpinnings of that, and then you figure out the semantics on how you want to convey that to the end user. Again, this is also an early area, how to make explainable recommendations or recommendations that can satisfy a user. And again, these are large neural network models. And then certainly there is, as much as we talk about systematic set of function calls, that is still sort of a higher level of abstraction, right? I made a function call, but sure. But then before that, what were the series of steps, right? So I think generally speaking, a good way to rely on it is or decent way that we see in our experience right now is just keep the debuggability mode on and look at the chain of thought reasoning, stack trace, and then see if there is any semantic explanation for it. Yeah, it's an evolving area still. Yeah. We have run out of time, but we'll be here. Vikram, I, and Brendan will be hanging out here. So please feel free to approach us anytime and ask us any questions there. But thanks a lot for your attendance.
Thank you so much. Thank you.